Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Wafi Takyuddin bin Usoid, and today I would like to present the introduction of this group project. And first and foremost, the engineering problem that we observe is to determine the thermal expansion coefficient of a Turonian. What is Turonian? A Turonian is a cylindrical protrusion utilized as a mountain or pivoting point. Basically, in mechanical engineering, it is one part of rotating joint where a shaft, which is the trunnion itself, is inserted into and turns a full or partial cylinder. Furthermore, this problem is aiming to shrink fit the trunnion into a steel hub. And in order to make it happen, the trunnion is dipped into a cooling medium to contract the outer diameter of the trunnion itself so that it can be fitted into the hub. Hence, some actions need to be taken, which is the diameter of the trunnion is measured earlier, and its value is 12.363, and it has been cooled from a room temperature of 80 Farad. And this is the figure of the trunnion that need to be shrink fitted into the steel hub. Okay, next is what you want to solve it. As mentioned earlier, in this project we have to determine the thermal expansion coefficient using the method that we chose, which are Gauss elimination method and Gauss elimination method with pivoting. Based on the equation alpha equal to alpha 1 plus alpha 2t plus alpha 3t squared, obtained using regression analysis where constant of the model are found by solving the following simultaneous linear equation. This is the simultaneous linear equation that need to be solved using the method that we chose. Then, why you want to solve it? The aim of this task is to determine the exact value of the shrink fitted trunnion into the steel hub. Thus, this task needs to be done to ensure that the machine can be functioned well before it can be used, to avoid any inconvenience in future, using the Gauss elimination method and Gauss elimination method with pivoting. One of the ways to know whether the machine is in the best condition or not is by checking the outcome of this machine itself, which is to have the exact value of the diameter of the trunnion to be shrink fitted into the steel hub. Okay, if to know whether the machine is in a good condition or not, if the values of the coefficient that calculated using these methods are the same with the estimation value, as the result, the machine itself is indeed in a perfect condition. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Daniel bin Zakaria. Okay, today I want to present about method. Okay, for 2.1, what is the suitable methods to solve the problem? The project problem is to determine the exact value of the shrink fit trunnion into the steel hub. In general, there are two types of system of linear equation to solve this problem, which are Gauss elimination method and Gauss elimination method with pivoting. These methods are also known as row reduction. Is a linear algebra algorithm to solve a system of linear equation. It is generally interpreted as a series of operations performed on the matrix of coefficient in question. For 2.2, how to solve it? Okay, there are two methods that we can use. First, Gauss elimination method. As given below, there are diametric contraction equation delta D, thermal expansion coefficient, and the simultaneous linear equation. Okay. The Gauss elimination method is used to solve the division 0 problem. For step 1, we need to eliminate A1 from row 2. This is A1 from row 2. So we need to sub into the formula, which is negative B over A times with A and plus B, and we'll get all the answer. And the answer, we need to place it into row 2, which we get new equation. For step 2, we need to eliminate A1 from R3, row 3. This is A1 from row 3, and this is same as previous step, which we need to sub into the formula and we'll get this answer. And this answer we need to sub back into the new equation, which is at row 3. And for the step 3, we need to eliminate A2 from R3. This is A2 from R3, row 3. And we sub into the formula and we'll get the answer, and we need to sub back to the new equation. Okay, as we can see, when we get all this 0, we can back substitution. From the third equation, we will get the value of A3, and by substituting the value of A3 in the second equation, we will get the value of A2. And by substituting the value of A3 and A2 in the first equation, we will get the value of A1. Hence, the solution vector is A1 equal to 5.00690 exponent negative 6, and for A2 is equal to 2.0087 exponent negative 9, and A3 equal to negative 1.4066 exponent negative 11. Okay, for second method, which is Gauss elimination method with pivoting. In Gauss elimination method with pivoting, we need to ensure that before doing elimination, we need to swap the absolute maximum value with the minimum value, so that the maximum value is always above the minimum value. Okay, for step 1, we need to swap equation 1 and equation 3 to get the maximum value of A11. Sorry, to get the maximum A11. As you can see, we need to swap this equation at the third row to the first row, and we'll get this new equation. And for step 2, we need to eliminate A12 from equation 2. We can use formula negative B over A times with A and plus B, and we'll get the answer. And the answer we need to put into row 2 equation. And for the next step, we need to eliminate A13 from equation 3. A13 from equation 3. As it is same step, we need to substitute the value into the formula and we'll get the answer. And for the answer, we need to sub back into equation 5. And then we need to eliminate A23 from equation 5. A23 from equation 5. And the answer we need to change, and we need to put in row 6 the new equation. And for the final answer, for equation 3, we can get the value of A3, and by substituting the value of A3 in equation 2, we'll get value of A2, and by substituting the value of A2 and A3, we'll get the value of A1. And the final answer for A1 is 5.0690 exponent negative 6, and for A2 2.0087 exponent negative 9, and for A3 is negative 1.4066 exponent negative 11. For 2.3, how to analyze and discuss the methods. The system of linear equation is a method of finding the new values of the coefficient of any function using the set of values that has been given. We can determine the unknown value of the coefficient using formulas in system of linear equation. Basically, in this topic, there are two types of matrix need to be solved, including 3 times 3 and 4 times 4 matrix. System of linear equation methods are divided into two types, which are Gauss elimination method and Gauss elimination method with pivoting. Based on the calculation above, the value of coefficient that calculate using these two methods of system of linear equation are clearly the same, as the estimation value, which are a1 equal to 5.0690 exponent negative 6, and for a2 is 2.0087 exponent negative 9, and for a3 it is negative 1.4066 exponent negative 11. So the project was successful. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Rozalani. My metric number is AA1844. And today I would like to present of my part is result and discussion. What are my result? Based on the question, we need to determine the value of A1, A2 and A3 and the result that we obtain from the calculation by using Gauss elimination method with pivoting is A1 equal to negative 1.4066 times 10 to the power of negative 11. For A2, negative 2.0087 times 10 to the power of negative 9, and A3 is equal to 5.0690 times 10 to the power of negative 6. And both method we get this answer. And this result are to find the thermal expansion of trunnion by solving the following simultaneous linear equation. And next, what are my finding? The result that we obtain from the question by using Gauss elimination method with pivoting is to solve the division zero problem. The algorithm for Gauss elimination method with pivoting is a little different from the Gauss elimination method. Before do the elimination process, the row needs to swap if necessary in order to get the maximum value in the first row, A1. In Gauss elimination method with pivoting, we need to ensure that before doing elimination, we need to swap the absolute maximum value with the minimum value, so that the maximum value is always above the minimum value. If the pivot element is small, this can lead to serious error in the solution. And the result that we obtain from the equation by using Gauss elimination method is to solve the division zero problem to get the thermal expansion coefficient to substitute into the diametric contraction equation, or delta D. And this calculation result are presented. The delta D is equal to 9.3938 times 10 to the power of negative 4 in meter. And why we get this result? And we find the best way to get the value thermal expansion trunnion is using system of linear equation, which divide into Gauss elimination and Gauss elimination with pivoting. This problem is aimed to shrink lifted the trunnion into the steel hub. The trunnion is dipped into a cooling medium to contract the outer diameter of the trunnion so that it can be fit into the hub. So the calculation has been made using both methods in order to estimate the expansion coefficient of trunnion. For this authentication problem, we use the elimination method to get the thermal expansion coefficient to substitute into the diametric contraction equation of the body. This calculation result are presented. The delta D is equal to 9.3938 times 10 power of negative 4 unit in meter. And why we get this finding? Gauss elimination method and pivoting is the most ancient and widely used method, and also known as row reduction. is an algorithm in linear algebra for solving a system of linear equations. It is usually understood as a sequence of operations performed on the corresponding matrix of coefficients, and in this case, Gauss elimination and pivoting method can be used to calculate the thermal expansion coefficient of tronium. Based on our findings, we can understand how the Gauss elimination method and pivoting works. In order to calculate the thermal expansion coefficient of tronium, this elimination method problem to get the thermal expansion coefficient to substitute into the diametric construction equation delta D. The thermal expansion coefficient has the unknown value A1, A2, and A3. To get the value of unknown, we must solve the three equations in simultaneously. Lastly, we substituting the unknown value into the integral of the metric contraction equation delta D. Um, that's all from me. Thank you.